All right, this is the circuits exam test review. You had the opportunity to pick it up during the class period. If you didn't pick it up, there is also a copy put on my webpage right where you accessed this. So you could get a hard copy of it there too, or have it pulled up also somewhere on your screen. Um, I'm only going to do the true false, the modified true false, the multiple choice, and the problem part. The grids I'm going to record on a separate piece so I can spend a little more time on them just so you're aware. And so let's get started. Okay, the first true false questions. In the schematic diagram above, none of the bulbs will have current. Well, remember that a circuit always starts and ends at the battery. So our first thing is okay, here's one pathway if we start at the battery and we can go through this light and get back to the battery. So yes, that light bulb works. Okay. Now if we go from here to here, the minute we get here, this is open. So nothing after this is going to work. So two of the three don't work, but in this statement it says none of the bulbs will have current. So this is a false answer. Now the circuit above in question 2 is a series circuit with two power sources in parallel. Well, first of all, if we start at a battery and go back to the battery, that is in series, yes. Okay, then I have one here that's there like that. But I have multiple pathways here. So this is not a series circuit. Series circuit means that there's a single pathway. Since I have multiple pathways to get back to the battery, that would mean that this is false as well, because this is a parallel circuit, not a series circuit. On number 3, this circuit has one resistor in series, okay, and three resistors in parallel. So we have to look at that. All right. Well, let's look at the one resistor in series. Okay, we start at this, we go here. Okay, well, all these are in parallel. That would be right. And then we go over here and we go through one and that. So this one right here is one in series. Now we need to check how many are in parallel. Well, this branch is 1 for 20 ohms, for 10 ohms, and 10 ohms. So that is three resistors in parallel as well. So this is a true statement about this circuit. Hopefully everybody's aware of series versus parallel circuits and complex so that you can identify them accordingly. Moving on, number 4, modified true false. Different household appliances use electrical energies at different rates. Well, my toaster versus my oven versus my refrigerator all use different amounts of electrical energy because electrical energy is power times time. Well, I don't have my toaster running as much as I do my fridge. So this statement is true. All right. On number 5, a conductor is a material that doesn't allow electrons to flow through it easily. Well, a conductor does allow electrons to flow through it easily. That's why wires are conductors. So this is a false answer, and we would need to change that underlined word to insulator instead to make this a correct statement. Number 6, the rearrangement of electrons on a neutral object caused by nearby charge. Okay, so this is just nearby charge is called induction. That is correct because if it had touched, it would have been conduction. So this is a true answer or true statement. The unit of power is kilowatt hours. Well, power is watts. So this is false. Okay. Power kilowatt hours would have to be electrical energy because remember, electrical energy is power times time. Okay. Resistance is the tendency of a material to oppose the flow of electrons. Well, that is correct. When we're talking about electricity, if the resistance is there, it's going to slow the electrons down. So this is a true statement. Moving on. All right, number 9. A path that allows only one route. So I want to definitely say only one route for an electric current is called parallel. Well, no, parallels multiple routes. So I'm going to X that one out. Parallel again, no. Series circuit or series current. Well, we didn't ever talk about a series current. We talked about current traveling in a series circuit. So your answer would be C on this one. Electric charge that is accumulated on an object is referred to. When you walk across the carpet, you build up electric charge. We say that that electric charge is static electricity. So your answer should be D on that one. Number 11. Three resistors are connected in parallel, have individual values of 4, 6, and 10, as shown in the above. Simplify this circuit to one resistor. All right. Well, these three right here are in parallel. So we have to do 1 over 4 plus 1 over 6 plus 1 over 10. And then we have to do the reciprocal of all of that. When you do the reciprocal of all of those in your calculator, if you do 4 and then hit the reciprocal button, plus 6, reciprocal button, plus 10, reciprocal button, then hit equal and hit the reciprocal button, you're going to get 1.93. Well, there's another resistor sitting right here, and they want us to simplify this circuit into one resistor. So I have to take all 4 of these and do this. So that's going to mean that I'm going to take 1.93 ohms as this equivalent resistance and add it to the 2. So my total resistance should be 3.9, which is D. Number 12. One source of constant electric current, which is what we used in lab, is a dry cell battery. That's what dry cell means, is a battery, just like the ones we used in lab to have our circuits work. Number 13, which of the following is a device designed to open an overloaded circuit and prevent overheating? So this is used for overloaded circuits. Well, a circuit breaker is done that way. If you overload your circuit in your house, the circuit breaker flips. A magnet doesn't have anything to do with overloaded circuit. A resistor slows the current down. It doesn't open if you overload it. And a transformer is used to increase current or decrease current. So your answer here should be A. All right, number 14, the reading on an electric meter was 5,345 kilowatts hours, and 1 month later it was 7,456 kilowatt hours. How much electrical energy was used during this 1 month period? Well, literally what they come out and do is they go ahead and subtract those values. So they're going to take 7,456, subtract 5,345, and you end up with an answer of 2,011 kilowatt hours. So your answer should be C for this problem. On 15, a reading on the electric meter was 2,345 kilowatts. 1 month later, it was 3,456 kilowatts. How much was the electricity going to cost if you're charged 10 cents per kilowatt hour in 1 month? So again, we have to do our subtraction. So we're going to do 3,456 minus our 2,345, and you end up with 1,111 kilowatt hours. You're then going to have to multiply that by the 10 cents you're charged for every kilowatt hour. That will come out to be your $111.10. And believe it or not, that's a pretty reasonable amount for a utility bill in 1 month. On number 16, an air conditioner uses 1,800 watts of power when plugged into a wall socket that operates at a voltage of 210 volts. What's the current flowing through the air conditioner? Well, the thing to remember is power is voltage times current. If that's the case, then I can find my current, which is I, to be power divided by voltage. So 1800 divided by 210 is going to give me an answer of 8.57 amps. Good deal. Hopefully so far you're understanding these. I did try to throw in some of this multiple choice to help y'all with the multiple choice section on your test. All right, number 17. The ohms through the circuit, this circuit would read what on a multimeter, okay? Well, the thing to realize is we first have to deal with this piece. So that's now going to become 16 ohms. That's going to be in parallel with the 4 ohm resistor. So after we do that, we have to use our parallel rules, which are going to be 16, 1 over 16 plus 1 over 4. And then we're going to take the inverse or reciprocal of all of that. When we do that, we're going to get 3.2 ohms. So that is now for this whole section is 3.2 ohms. So now once we have 3.2 ohms, we're going to have to add that to our final resistor, which is here, and that's going to be our 2 ohm resistor, which is going to give me 5.2 ohms. So our answer should be B. 18, what's the equivalent resistance for the resistors in the figure? Again, we have to start with this section right here. So this becomes a 10 ohm resistor. Well, then we're going to deal with simplifying this whole piece, which is 1 over 10 plus 1 over 10, and then we take the reciprocal of that. So that's going to give me 5 ohms. Once I have that, I'm now going to have to add in this final 5 ohm resistor, which is going to give me 10 ohms total. So my answer choice would be 1 times 10 to the first ohms. Number 19, what's the equivalent resistor for these resistors shown? Well, we start off with these. These are in series with each other. So 3 plus 3 plus 3 is going to give me 9 ohms. Well, now I have a 9 ohm and a 3 ohm resistor in parallel. So in parallel, I have to do 1 over 9 plus 1 over 3, and then I have to take the reciprocal of that. So that's going to end up with 2.2 ohms. So our answer should be B. Number 20, 3 resistors with the value of 64, 135, and 92 are connected in series. The key word there is series. What is their equivalent resistance? Well, on series circuits, you add them. So we do 64 plus 135 plus 92, and we would find out that that is 291. So C would be your answer on that one. On number 21, we have resistors with values of 15, 41, and 58. They are connected in parallel. So when we're using our parallel laws, we have to go ahead and say that it's 1 over 15 plus 1 over 41 plus 1 over 58, and we have to hit equals and then take the reciprocal of all of that. When we do that, we get 9.2 ohms. Remember, you have to pay attention to what type of circuit you're dealing with and follow the rules accordingly. All right, the current in a light bulb is 1.425 amps. How long does it take for a total charge of, that should be 0.2919 coulombs to pass this point? All right, we are going to have our formula, which would be that we'd have 1.425 amps equals 0.219 coulombs divided by time. So we're actually going to have to take 0.219 divided by 1.425, and you should come up with the answer of 0.15 seconds. Now in these last parts, we're just drawing circuits. We want to draw on this first one a series circuit. So to do that, we are going to draw a 9-volt power source. So I'm going to do a battery and label it 9 volts. I need an open switch. So I'm going to have an open switch right there. And then I'm going to have 3 light bulbs in series. So I'm going to do a resistor with a circle, a resistor with a circle, and a resistor with a circle. Those are my light bulbs. And then I'd go back to the battery. Now key here is that they all have to be in a single pathway. All right. Now for 24, we're going to do a parallel one instead. There are lots of different ways that you could do this. I'm still going to do a battery source, which is 9 volts. And then I'm going to do an open switch. Okay. And then I'm going to branch off into 3 resistors or light bulbs. And then I will branch back together, and then I will go back to the battery. That's one way. You could do the individual boxes as well. Both of them would be correct. But the key here is multiple pathways. Multiple. Yes, I do know how to spell. So hopefully this helps you. Like I said, the rest of this review will be done separately, so I'll do a separate recording for this, for the remainder of it, which is going to be your circuit diagrams. Okay? Hopefully this helps. Good luck on your exams.